Hello everyone, I'm Niharika Shahi, Data Science and Business Analytics Intern at the Sparks Foundation, and here I am presenting you the task 1 of this internship. And the task 1 is prediction using supervised learning. And my aim is to predict the score of a student if he or she studies for 9.25 hours a day. And we will be using Python for this code. First of all, we will be importing all the important libraries and packages required. The libraries include pandas, numpy, matplotlib.pyplot, sklearn.model_selection, sklearn.matrix. Most of these libraries are required for manipulating the dataset, applying numerical operations on the observation, plotting the graphs, splitting the data into training and testing sets, as well as building the linear regression model. After this, we will be importing the dataset. For this, in the command number 2, we have read the URL provided for downloading the CSV file. In the command number 3, we have downloaded the CSV file using the same URL using the command read_CSV. In the command number 4, we have displayed some of the initial elements of the data so that we can have a knowledge of what our dataset contains. The dataset contains two variables, hours and scores. Now we will be plotting a graph between hours and scores so as to know what is the relationship between these two variables. From the graph plotted, we can clearly see that hours and scores have a linear relationship, kind of a linear positive relationship, which displays the more a student studies, the more he or she scores. After this, we will be splitting the data into two parts, that is training and testing. We have split our data in the command number 7 in two parts, that is in the ratio of 80 and 20 using the command train_test_split. After this, we will be building a linear regression model. We have used the library linear regression and we have fit a linear regression model on the training dataset, and we have made a prediction using the testing dataset. After building the model from the command lines 9 to 12, we will be now checking what is the accuracy of our model. For this, we will be using the mean squared method. In the command number 13 and 14, we have displayed the mean squared error and it comes to be 4.64744. And we already know that lower the value of mean squared error, higher is the accuracy of our model. Now we have plotted the best fit line to ascertain the relationship between the points in the scatter plot. With the graph plotted from the command number 15, you can clearly see that both of these variables hours and scores have a linear relationship, which is mostly positive. Now we will be predicting the values of the test data set. This will help to ascertain the accuracy of the model. Now we will be comparing the actual value with the predicted value. The actual value is contained in the y_test dataset, which we have stored in df2 using the command line 16. And then the values that we predicted in the variable pred has been also stored in the variable df2 using the command number 17. And you can clearly see in the output of the command line 17 the scores that the actual dataset contained and the scores that we predicted using our linear regression model. We know that our MSE, that is mean squared error, is 4.64. So the error in the data frame df2 is shown by comparing the actual values against the predicted values. Now we have created our linear regression model. Now we will be able to predict the score of a child as our aim who studies for 9.25 hours per day. Now we have stored 9.25 hours in a variable hours under the line 18, and then using our linear regression model we have predicted the score for the same hour, and it comes to 93.69. So we can clearly see that the model is able to predict the score when a student studies for 9.25 hours a day. She may be able to score 93.691732 score. Thank you.